Hello, I'm Roman. Welcome back to the series of the videos Neural Networks from Scratch in Golang, where we're using a book called Neural Networks from Scratch in Python, but we're writing everything with the Golang, as you can guess. And a reminder, I have a Discord channel that you can join. It's growing slowly, and channels are growing slowly, Discord growing slowly, but they are growing. So more and more people join. You're welcome to join too. Then I have another YouTube channel where I'm recording talking head videos. I would name them like this, around tech industry and decoding. I'm a little bit silent there for the past months, but it has some personal reasons. But I will get back on the track in the August, right? August, yeah. But what we're doing here, so here, not this one. So here we are at the chapter saving and loading model and their parameters. And actually, I've been investigating a couple of the videos, what I need to do to actually do this. The main thing I need to do is to save in the model and load in the model. And what is written here basically doesn't make much sense for the Go implementation because of the big difference between how the Go works and how the Python works. In Python, you can do all sorts of the dynamic magic, and you can dump even the class names automatically, and unload them back. With the Go, it's a little bit different. Well, it's actually a little bit, because I think I showed it in the previous times. For example, this example represents the problem that I have. So I have, for example, something called the model, right? It has the array of the layer interface, and I can try to annotate it with a JSON attribute. So I will use the JSON marshalling just because, well, this library, this code that I'm building is purely for the educational purposes. So of course, in the production way, there is nobody will store such big data in the JSON. Probably it will be something, some binary format with the compression, etc., so you can reduce the space, but it's not relevant here. So I will annotate it with the JSON. But the main problem, you can see that this is the interface, and this is the interface, and there I have it even more. So here, yeah. So imagine that, okay, I don't need this. Imagine that I have, okay, clear, again, go run main, right? So it actually dumps the values. But you can see that there is no information about type that was behind the interface. And for the accuracy, it's just an empty object, because, well, what I need from the accuracy is more or less, I need a different implementation of the calculate methods. And again, if we go to the main and we'll try to load, and we will try to load this JSON into the model struct, we will get an error because can't run marshal object into the Go struct field model layers of the type main.layer interface, because it doesn't understand which concrete implementation it has to implement. So what do we do? I already understood that I need to implement a custom marshalling in my case, especially because, well, just take a look. Not for the input. For example, for the layer interface, I have this amount of the implementations, right? Same for the loss, right? 4 implementations for the optimizer. Well, currently it's only one because I forgot to follow implementations from the other optimizer. I forgot to follow the interface, but for the accuracy, again, 3 different accuracy calculations. I started, and yeah, I've been telling that this week is kind of hard for me, so I'm it's a little bit harder for me to put my thoughts into, to put my thoughts, organize my thoughts inside my head. So I'm a little bit kind of harder for me. So we'll start. But okay, yeah, I need to do the custom marshalling and the marshalling. Most likely what I will do, I will just build the JSON format that I'm going to store like purely manual. And probably it will be done in a way that each implementation of a concrete interface will implement marshalling and unmarshalling for this part. So I can compose the final JSON from the pieces that I need. So what do I do? Actually, in the utils, I want to create... At first I thought that the model will be responsible for saving and loading, but since I cannot annotate the fields, and most likely I will need to create some proxy structs that I will be using for this serialization and deserialization. So I'm going to create a separated class that will do this. And also, I think it's, not the model's responsibility to know how to, currently, for example, I will be storing it in a JSON. Maybe then I will change the format. Maybe I want to have several types of the serialization. So we will have most likely the interface that describes how save and load of the model. And then we'll have a couple of the implementations. But for now, downloads, model, I think I will put it here. How I would write it? It's a very good question. Model. Model saving. Let's ask ChatGPT. How you would write name a struct that saves and loads model data. Model data handler. Okay, model data. Storage. No, it's more like actual storage. Model data provider. Okay, so we... Oh, okay. Okay, so we have the model data provider. It will be in the... So I have the type interface, model data provider. Yeah, would not be that good at naming. Okay, but what I would assume? I would assume store has string, return error, and loads. Same path, string, and error, but actually that will return model or error. And this one will take and model, the reference to the model. Okay, then we're going to implement this. So we will have JSON model data provider, but I think I can remove it, right? So what do we do here? We do this provider, right? And store, which will be the pass string, and model will return error, right? Return nil. And then we have load, right? We don't need this, and here that will be model error. Do I need actually this? Yes. Yes, that will be this, and return here. Correct? Correct. What it means, I don't need this, and this. Okay, I will, this is save, right? Where we have store, actually store this one. Missing import path. And then wait, this, and oops. Call finalize, yeah. So it means what you don't like here. Yes, we don't need the OS. No diagnostics. Okay, do I have something here? Okay. Where are we going to use it? For example, we have the run fashion model. For example, we trained it, we evaluate it, and then we go into, so we have the data provider equals to model JSON data provider and data. Okay. Data provider. Store and model. Oh, and the path. Not that. Okay, assets slash fashion JSON, right? Yeah, we need to pass the reference. That's it, right? Oh, okay. How to marshal custom sequence, more or less. Okay, so the load, we actually, and then, for example, what we can do this, loaded model equals to model, model that's model this one. Then we have data. Oh no, actually it's loaded model equal to data provider error equal to data provider load from the assets JSON. Okay, if error nil, then we do this log panic. In my case, that's fine. And load model evaluate against validation data. And what's the next? Batch size. Cannot use. Why? We cannot use this. Okay, this is basically how it should what should happen. And this, right? And actually need a way to test it. And I think the way I can test this is the number of the epochs, right? Epochs equals to 1 for now. Epochs. And it here. Analyze description. Okay. Why I created the model data provider interface? Because then if I would like to do the what's called checkups, not the checkup, checkpoints during the training after the each epoch. For example, I can do, something after the epoch is done, where it's at this moment, right? I can do something like data provider, store, and blah, blah, blah. And then there are some things that, well, first I don't need this. I will rearrange things a little bit. First I have the layers, then I have this, and they should be public, right? Like this, like this, like this, and like this, because I will need a way to access them. Okay, so we have layers, right? I need to change it to the layers, and I want to ask for confirmation of this one. Yes, yes, yes. Trainable layers. No. Yes. No. 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 Yes. Yes. Yeah. This one. This one. This. Okay. Okay. Changed here. Then next one we have, I think it will be always dot loss. How I would decorate it like this, right? So then it will be loss. Which one is selected? Wait. Mm. Mm. Yes. Mm-hmm. 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 Okay, then I will do the same for accuracy. That will be accuracy, right? Okay, yes, yep. What is left? Optimizer. Okay, we have the percentage, we have coordinated optimizer, then we have optimizer. And it would be much efficient for me for the next time to configure the rename action for the LSP. But I think I configure it, but maybe I can .files vim lua think plugins. That probably comes with this one, right? Rename jar. But jar, it's something else. No SP reference. Wait. Okay, it's declared somewhere else that the jar is for references. I need to scope key maps, I think. Reference references. And where is defined? Telescope key maps rename space yar. Okay. Okay. And that will be the internal one. Then okay, for the accuracy, do I need? Okay, actually have. I don't need, probably. I will need only the function, but I don't need to store the actual state. So this is why I will have the initialization is empty. I think for the regression I will need something, right? So and this one. I think I can do this already. Precision, right? And this for this one. Inputs I don't need. Outputs, the inputs, the question. This is same. Outputs, the inputs, probably not. Data sets, no. Well, layer will come back to you later. I have the basic base loss. Layers should not be exposed because they will set it as set layers during the training when needed. Okay, for the binary cross entropy, it's base loss. Categorical base. That's base loss and base loss, but where I have the base loss? Oh, that's this one. Okay. Model. The model is fine. Okay, this one is the most weird case. Okay, for the atom, we don't need the iterations, although maybe we need. I will need iterations when I need to store the progress of the learning. It's actually a good question. Should it be exposed to storage? Right? Then it's just an interface. The same here. Okay. And we have the layer, which has inputs. No, we don't need. Everything else is exposed, but not everything will be stored. This is the dense layer. For the dropout, learning rate, okay. Where I use the binary mask. Binary mask is the copy on the forward. Okay, so basically everything that is calculated on the forward I don't need, so what do they removing? So they remove inputs, outputs, the inputs, the weights, and the biases. Okay, so basically all the calculations, but okay, inputs. Interesting that they forgot the binary mask. Wait, dropout layer. Question, should it be stored? Because I honestly don't know. Input layer shouldn't be stored at all. And there is a dense layer and the most interesting one. Okay, so what do we have here? Store. How it's defined dict as map string any. Actually don't know how to map. No, I need the type. Type map code types. Guides. What a weird way. Okay, so that will be string any, right? No. String any. String. Okay. That will be then, you know, this equal to I know, make bytes, I know what. Okay, that works. New difference in the mind. So we can store. Oh, it's actually not any, it's interface, right? Test, you know, for example, dict, no layers, right? Then equal to make, I don't know, what's the type? The bytes. Oh, come on, Python. And then, I don't know, dr equal to JSON Marshall dicts, right? If error, then return error, right? And then, I know, file write d, that's it, kinda. New difference in map update. What it means? Okay. The statement said the key wrote the value of 66. For example, equal to model and model JSON provider equal to, and then provider store sets model JSON and then m, right? Run. What will happen? Assessment to entry in new map. Okay, which means that I can do assets model JSON, right? Okay. Dict. Okay. So basically, this is the JSON that we. Okay. So, okay, I prepared the coding structure, prepared this one. So, yeah, I'm slowly going to reach what I need. I need to check, I think, two properties if they should be, if it makes sense to store them or not. But yeah, the next thing is to build this dictionary. Yes, it will be stored in the memory, but I don't have a big model, so I can load, you know, everything in the dictionary and then store it on the disk. So the next thing will be to, for example, take, well, the next, for example, what is the next task? Next task is to coordinate storing of the layer of the all of the implementation of the layer interface in a way that it will store all of the data that is needed for a specific struct plus the class. So then we can traverse it back. For example, when I will load, I will go through all of the items inside the layers JSON fields, and I will check the type. And for example, if this type is some type, right, concrete type, then I will instantiate and add it to the model. So we'll basically reconstruct the model based on the data from the JSON. The only thing that we won't instantiate anything random, we'll just load all the parameters from it. Okay, that will be in the next episode. So stay tuned and I see you tomorrow. Bye bye.